All right, let's get right into it. Today, we are on a mission, a pretty important one, actually. We're going to crack the code of one of the most common and, let's be honest, crucial technical hurdles out there, the SQL interview. We're going to arm you with the concepts and, more importantly, the patterns you need to nail it.
So here's the plan. Think of it as our mission briefing. We'll kick things off by setting the stage, then get into the fundamental language categories. After that, we'll dive into some crucial design concepts, face off some common commands, and finally, tackle some real-world queries used by the pros. Let's do this. Okay, so first up, let's talk about the mission itself. Look, in today's top tech and data roles, knowing your way around SQL, it's not just a nice to have anymore. It's table stakes. So think of this explainer as your field guide to passing that test.
You know the feeling, right? You see that perfect job posting. You've got the skills, you've got the passion, but then you see the technical requirements, and you just know they're going to grill you on how you handle data. So how do you even begin to prep for the kind of questions you're about to face? And yeah, these are exactly the kinds of puzzles you'll be solving. We're talking big names here, like Amazon and Microsoft. They want to see if you can solve real-world problems. Can you actually find duplicate records to clean up a messy dataset? Can you figure out that classic puzzle of finding the second highest salary? It's not about memorizing definitions. It's about applying what you know.
Okay, so before we can start writing those pro-level queries, we gotta go back to square one. Welcome to basic training. We need to get a solid handle on the absolute fundamentals of the language itself.
So first things first, what is SQL anyway? When you boil it all down, it's basically the universal language for talking to relational databases. It's how we ask for data, tell it to change data, and even how we build the database structure in the first place. You can pretty much group all SQL commands into three main jobs. I like to think of it this way. You've got DDL, which is the architect. It builds the database with commands like create. Then there's DML, the librarian, who manages all the books, the data, inside, using select and update. And finally, you have DCL, the security guard, controlling who gets a library card with grant and revoke.
All right, now that we've got a grip on the language, let's talk about design. This is where things get really interesting. Keys and indexes, these are the essential tools in your armory. They're what makes sure your data stays clean and your queries run super fast.
Okay, this one's a classic interview question, and for good reason, right? It's not just trivia. Asking this tells an interviewer if you get the core rules of data integrity. A primary key, that's the ultimate ID for a row. It can never be null, and you only get one per table. A unique key is, well, it's like its slightly more relaxed cousin. It also makes sure values are unique, but it'll let you have one single null value, and you can have more than one in a table. See? Knowing the difference isn't about memorization. It's about seeing the pattern of how a database keeps itself organized.
And that brings us perfectly to how the data is actually stored on the disk. A clustered index is like a dictionary. Think about it. The words are physically sorted alphabetically. You can't sort it two different ways at once, which is why you only get one clustered index. A non-clustered index, on the other hand, is like the index at the back of a textbook. It's a totally separate list with page numbers or pointers that tell you where to find the real information. And just like a book can have multiple indexes by subject, by author, a table can have many non-clustered indexes.
All right, time for some command showdowns. These are those classic versus questions that interviewers love because they test for a deeper level of understanding. It's not just about what a command does, but how it does it, and more importantly, why you'd pick one over the other.
First up in the ring, delete versus truncate. Now, on the surface, they both seem to do the same thing, get rid of data. But an interviewer asking this is really checking if you're thinking about performance, about system resources. Delete is like a scalpel. It's a DML command that removes rows one by one, and it logs every single deletion. So it's slow, but it's precise. Truncate, that's a bulldozer. It's a DDL command that just drops all the data pages. It's incredibly fast, but it's an all-or-nothing deal. Choosing the right one shows you get the pattern. Do I need surgical precision, or do I need a total fast cleanup?
This next one is all about timing, specifically the logical order a query runs in. Both where and having are filters, right? But the key is when they filter. The where clause jumps in early. It filters rows before any grouping or calculations happen. The having clause, though, it waits. It filters the groups of data after they've been created and aggregated. So, simple rule, use where to filter the raw data, use having to filter the results of your calculations. Okay, foundation is set. Basic training is complete. Now for the really fun part. Let's put these skills to the test and tackle some real-world problems.
We're going to look at the exact query patterns that the pros at top companies use to get the job done.
So here's your first challenge. It's a super common business problem. You've got an employee table, you've got a department table, but there's a data quality issue. Some employees aren't assigned to any department. How do you pull a list of just those unassigned employees?
The perfect tool for this is the left join. And here's why. It's designed to grab every single record from that first table, our employee table, and then any matching records from the second one. But here's the magic trick for this problem. What happens when there's no match? The database gives you back a null. And that null is the perfect flag we can use to find exactly what we're looking for. See, it's not just a command, it's a pattern for finding what's missing.
And boom, here's that exact pattern in action, a type of query you'd see at a place like Uber. You just do a left join from employees to departments. For any employee who doesn't have a match, that department ID field is going to be null. So the last step is simple. You just filter for it. Where department ID is null. It's clean, it's efficient, and trust me, it's a pattern you'll use all the time.
All right, let's ramp up the difficulty a bit. Finding the single highest salary in a company, that's easy. But what if your boss comes to you and says, I want to see a ranked list of the top earners inside every single department? Suddenly, a simple max and group by isn't going to get you there, is it?
For this kind of next-level analysis, we need to break out a real superpower, window functions. And here's the absolute key difference. Regular aggregate functions, like sum or count, they collapse a bunch of rows down into one single result. Window functions are different. They do a calculation across a whole window of rows, but they keep all the original rows. This is what lets you do amazing things like ranking, running totals, and moving averages.
So let's see this superpower in action. In this Amazon example, we're using the rank function, and the magic words are over and partition by. Partition by department ID basically tells the database, hey, treat each department as its own little group. Then, within each group, it ranks the employees by salary. This gives you a ranked list inside each department, something that's totally impossible with a simple group by. It's incredibly powerful stuff.
Okay, one last common challenge, and this one is all about being a good teammate. As your logic gets more complex, your queries can turn into this horrible, nested mess of subqueries, right? So how do you write clean, readable code that someone else on your team, or even you, 6 months from now, can actually understand? The pros answer? It's the common table expression, or CTE. You'll spot them because they start with the keyword with. A CTE lets you create a temporary, named chunk of data that only exists for that one query. It's kind of like creating a temporary variable in programming. It lets you break down a huge, complicated task into simple, logical, readable steps. This query from PayPal is a fantastic example. The goal here is to show each product's sales as a percentage of the total company revenue. Now, you could do this with a messy, nested subquery, or you could do it the clean way. First, you define a CTE called total revenue to calculate that grand total just once. Then, in your main query, you just join your sales data to that simple pre-calculated value. It's the professional's pattern for writing clean, step-by-step logic that actually makes sense.
So let's debrief. What's the big takeaway from all this? We've looked at a lot of code, a lot of concepts, but the goal really isn't to memorize every single query line for line. Honestly, that's not going to get you very far. The real key, the thing that will make you successful, is recognizing the underlying patterns. You need to find stuff that's in one table but not another. That's a left join pattern. You need to rank things inside of categories. That's a window function pattern. You need to untangle a complex multi-step calculation. That's a CTE pattern. Once you start to see these patterns, you can pretty much solve any problem they throw at you. So the only real question left is, which one of these patterns are you going to master first?